This is lesson 28 for 8th grade, and today we're talking about scientific notation for large numbers. We will eventually get into scientific notation for very small numbers, but today we're just going to focus on the large numbers. Basically, what we want to get down today is that we want to understand that we can represent numbers in different ways, and we'll still have the same number. It may look different, but we will have the same number. So representation in different ways. And we want to understand that multiplying by a power of 10 will move our decimal to the right. And we'll show you what that means in a second here. And with knowing our first two objectives here, we're going to combine that to learn the format for scientific notation. This next slide will give us a brief introduction as to what scientific notation is. It's something that we've seen before, and it's something that is used a lot, especially with really large or really small numbers, because it helps us save space. So, I'll read through this here. So, scientific notation is a method of writing a number as a decimal number times the power of 10. So that's where our power of 10 comes in. Scientific notation is a useful way to express and manipulate very large or very small numbers that take many places to express in standard form. Okay? Now standard form is just how you would write a regular number. Okay? So for example, the speed of light is about 300 million meters per second. So this would be the standard version of it. In scientific notation we write 3.0 times 10 to the 8th. So this number and this number are the same thing, except for this one's a lot shorter to write, and this one's a little more drawn out in standard form. And obviously numbers get much more bigger than this, so you can see where this would come in handy. So the first number, 3.0, is the coefficient. Okay? The coefficient is written with one non-zero digit to the left of the decimal point. So that would be your 3. One non-zero digit to the left of the decimal point. Basically, your rule of thumb is whatever number is right here has to be between 1 and 10. Okay? So, a number between 1 and 10. Or if you like to remember that there's just one non-zero digit to the left of the decimal, that's fine too. So the power of 10 is the multiplier that turns 3.0 into 300 million. And it says to notice that the exponent, which is 8, corresponds to the number of places the decimal point shifts when the number is written in standard form. So this 8 here, this is one of our objectives, and it's 10 to the 8th. That tells us that this decimal is going to move 8 spots to the right. And wherever we have a spot, we fill in with a 0. So just to show you, 3 here was our dot. So it would be 1, 2, 3, 4, 5, 6, 7, 8. Any of these little loops gets a 0. And then we fill in with our commas. And that's where we get the 300 million from. Okay? So we should be able to convert from standard form to scientific notation form and vice versa, go from scientific notation to standard form. This place value might be a good table to look at if we're unsure of where the place values are. We have our units, our ones, so ones, tens, hundreds, thousands, ones, tens, hundreds, millions, billions, trillions. Keeps going. And it tells you what power of 10 is for each of them. So 10 to the 0 power is 1. And I'm going to say this a bunch this year. Anything to the 0 power is 1. So if you see 500 to the 0 power, that's 1. 300 to the 0 power. Negative 5 to the 0 power, it's all 1. Okay, so anything to the 0 is 1. 10 to the first is 10, 10 to the second is 100, 10 to the third is 1,000. Keeps going all the way up to 100 trillions, which would be 10 to the 14th. Okay? So, if we look at this example, It says Earth's average distance from the sun is 93 million miles. Write 93 million in scientific notation. Okay? So remember, we want one non-zero digit to the left of our decimal spot, or we want that number to be between 1 and 10. So we're going to say 9.3. So one non-zero digit to the left of the decimal, and this number is also between 1 and 10. And then we want to count how many spaces, because our decimal is sitting right here right now. We want to count how many spaces it takes for us to get to here. So 1, 2, 3, 4, 5, 6, 7. Could have gone the other way too. Knowing that your decimal would be here, count this way. 1, 2, 3, 4, 5, 6, 7. Until you get to the end. So this would be times 10 to the 7th power. So that would be 9.3 times 10 to the 7th. And we would actually write miles here for units. Although it did just tell us to write the number. Anyway, that's how we do that one. I'm going to check my time. I'm running out of space on here. We're doing okay. I have to delete some old videos so I can get some more room on there. I'll end up proving that anything to the 0 power is 1 later when we get there. So if that's confusing, you can look it up or wait for me to explain it. Alright, let's take a look at this one here. It says, when Brigetta finished the 1,500 meter run, she announced that she had run 1.5 times 10 to the 6 millimeters. Write that number A in scientific notation and B in standard form. So 1.5 times 10 to the 6th millimeters. So A, 1.5 times 10 to the 6th millimeters. That's our A. They just wanted us to write that out in scientific notation. Everything looks good. This is one non-zero digit to the left of our decimal, and it's in between 1 and 10. 1.5 is between 1 and 10, so that's another way you can do that. And it's times 10 to the 6th, times the power of 10. That looks good. So for B, we take our 1.5, and we're going to move that decimal 6 spots to the right. 1, 2, 3, 4, 5, 6. Fill these with zeros. And then every third 0, we're going to add a comma. Right there. So that looks good. 1, 2, 3, 4, 5, 6. So that's a lot of millimeters. Yep. And this is a good way to convert from different units, especially with the metric system, because that goes by a power of 10. So, yes, that is what we'd be looking for there. Alright. And one thing that we want to point out too with calculators, a lot of students probably already have witnessed this, but scientific calculators will display the results of an operation in scientific notation if the number would otherwise exceed the display capabilities of the calculator. So, for example, if they multiplied 1 million times 1 million, the answer is 1 trillion, and it contains more digits than the calculator can show. So they might show, there's a bunch of different ways they could show it. 1 times 10 to the 12th, 1 point, and then they have a little 12 up there. My calculator would show 1 e to the 12th. That would mean 1 times 10 with the exponent of 12. A bunch of different ways that they show that. So, just so that we're aware. Alright, and we're going to go over plenty of these in class, but this is just a brief interview to scientific notation. Or introduction. We'll see you tomorrow.